everyone, welcome to our channel After School. This is Gayatri Patel, your physics ma'am. How are you all? And this video is specially for class 10 students of both state boards, API and TS state board and CBSE class 10 students also. So the name is electricity. The name of the chapter is electricity. In the board is CBSE, but in SSC board, TS and AP boards, it is electric current. Okay, in this video, as thumbnail says, we are going to practice all the numericals from this chapter, all the possible numericals for this coming board exams. Got it? And here I have taken all the previous questions from all the previous year questions. Okay, AP board and TS boards previous last 5 years question papers, and I have gone through CBSE papers, and I have considered and the questions, the numericals I have considered from our previous year question papers. Okay, both I have referred both CBSE and APTS previous year question paper, and then we are going to solve them. Got it? But before going to solve, we need to know what exactly are the formulas we need to know, right, from this chapter. So first, let's start with electric current. What is electric current? So we already know it is the amount of current passing through the any cross section in given time, right? So that we can consider, that we can represent mathematically in this way. I is electric current. I is equals to charge per unit time. So here Q is charge and T is time. Here they have already mentioned I is equals to amperes. So Q's charges units are coulombs and time unit is, of course, it is second. So to understand this, to remember this, you need to know this. So to remember this easily, you just need to know this pyramid or triangle you can consider. So from this, you can write all the three quantities formulas. So here I can write, so I is equals to Q by T, right? So it is simply, I can write Q by T, and I can also write Q is equals to, from this, Q is equals to what it is, I into T, right? So it is I into T. And from here I can also write T is equals to, so here T is equals to Q by T. Okay, so it is Q by T. So from this single pyramid or from single triangle, we can write all these three formulas, right? So anyway, if you remember this one formula, that is also very good enough to solve current problems. Okay, and not only this current, we have one more formula that we will discuss it in few minutes. And next formula is voltage. So this is also known as potential difference. Okay, so potential difference is denoted with the letter P. Okay, so what is potential difference? It is nothing but work done on charge. Okay, work done by the electric field on charge. So we can write this as V, voltage is equals to W by Q. So same for this also, we can remember this triangle. So here V is equals to W by Q as it says, and W is equals to V into Q. Okay, so I can write W is equals to V into Q, and Q is equals to W by P. Got it? So this is how we can write formulas. We can change all the formulas. Got it? And then now one more important formula is that drift velocity. Okay, so there is a least probability of asking for these formula questions. So here what it is saying is, what is drift velocity? It is the average velocity of average speed of all the electrons. Okay, average speed of all charges we can consider, right? So that charges are, can be positive charges or can be negative charges, but here we are gonna represent that charge with letter E. And so here drift velocity is represented with the letter Vd. That means drift velocity, that is equals to I current by N. N means number of electrons, or you can also consider it as number density, free electron number density. And E is a charge. It can be a positive charge, it can be a negative charge. So according to question, we will consider and A is nothing but area of cross section. Got it? So here from this formula, we can also write I. I is equals to, simply you just need to take this denominator to LHS. Then it is VD into NQA. Got it? So here in the place of E, I have considered Q. Okay, not an issue. And Ohm's law, very important formula it is, and also statement. You need to also practice the diagram and activity, all the things from this concept. Okay, so what this Ohm's law says? So in any current carrying conductor, velocity, sorry, not velocity, here V indicates voltage. Voltage between two, potential difference between any 2 points in a conductor is directly proportional to the current passing through. Okay, so if current increases, then voltage increases. If current drops, then voltage also drops. Got it? But here, if we remove this proportionality, we will get one constant, that is R. So this is nothing but resistance. Yes, we do have formulas for resistance also. We'll discuss it in few minutes. And this is the main formula of Ohm's law. And it can be written as, so here as you can see from this triangle, I is equals to V by T. Okay. And I can write V is equals to, here you can see V is equals to I into R, right? I into R. And also I can write R is equals to what it is? V by I. Got it? So R is equals to V by I. So from this, in this way and by using this formula also we can write I is equals to, what is it? V by R. So by using this formula also we can find current. So there are so many ways to find current, but according to given information we need to choose the formula. Got it? And the resistance, just now we have mentioned that it is in Ohm's law, there is a proportionality constant, right? That proportionality constant is nothing but resistance is nothing but an abstraction to the flow of charges in a conductor offered by the conductor or a material, right? So this resistance is directly proportional to length of the conductor, and it is inversely proportional to area of the conductor, right? So you need to know these two formulas as well, because since it is not included here, so we don't need to know this relation. But no, these two relations are combined here, and we can write it like R is directly proportional to L by A. Then we got a proportionality constant, R is equals to rho L by A. This rho is nothing but resistivity. Got it? And R is nothing but rho into L by A. L is here length of the conductor. A is area of cross section, right? And rho is resistivity and R is resistance. R resistant, if the difference between these two is R depends on length, area, all these physical characteristics of a material, right? But resistivity does not depend on its length, area, all these physical terms, but it only depends on the material. Got it? So this is the main difference between resistance and resistivity, and these are the formulas. Fine. And units for resistance is ohm, and here units for resistivity is ohm meter. Okay. And next important point is power. Power, what we know about power, power is nothing but rate of doing work, right? So we can simply write power is equals to W by T, but it not in electricity. So in electric current chapter, we can write power is equals to voltage into current, right? But we already know V is equals to IR, right? So if I substitute this here, then what I can write? So V, at the place of V, I'm writing IR, then it will be I square R, right? But here I can also write I is equals to V by R, right? So I am substituting this I here, then I can also get V square also by R, right? So these many forms of these many forms to find the power of a circuit. Okay, power consumption. Fine. And next very important point is that resultant resistance in parallel combination and series combination. So if we have resistance, we can connect them in this way. So here what's happening? So all the ends are connected to one end of the terminal. Okay, and all the other remaining ends are connected to other one end, right? So this type of connection is known as a parallel connection. And here one more important point, that in parallel connection, voltage is constant. Voltage is constant and current is variable. Current varies in parallel combination. And here you need to know the formula of finding resultant resistance. What is that? 1 by Rs is equals to sorry, 1 by R resultant resistance, you can write 1 by Rs is equals to 1 by R1, 1 by R2, 1 by R3, etc. If there are 4, you can write 1 by R4. If there are only 2, then 1 by R1 plus 1 by R2 is enough. Right? So this is the resultant formula, resultant resistance formula. Okay, by using this, you can simply find the resultant resistance in that whole circuit. Now, what about series? So in series, yes, there here too we have a constant term and a variable term, but that is here in series current is a constant term. Okay, so voltage varies throughout the circuit. So here how to find this resultant resistance? This is very simple. That is, so here R1 plus R2 plus R3, so on. Got it? So this is how we can find the resultant resistance in series and parallel combination. And next comes is Kirchhoff's loop law. Okay, in loop law, we generally find the what is loop law? Sum of the voltage of any component across any component is equals to 0 throughout the circuit, right? So here algebraic sum of voltages across any component in throughout the circuit is 0. But to find this, what we need to do, we anyway if it is a circuit, then what we'll do? So we'll simply take a loop, right? So from this point to again to this point. So to move this in this loop, when we are traveling from one across any component or any battery, then we need to know some points. Okay, we need to take sign convention for voltage. So what is that? So first, sign convention for batteries or EMFs, and also resistors will discuss. So if we are going from negative terminal to positive terminal, then what happens to our voltage? Voltage will be positive. Okay, so here we'll get plus V, right? So whenever we hit in the loop, if we hit the negative terminal, then it is positive. If we hit the positive terminal, then it is negative, right? Opposite. And when it comes to resistors, if we are traveling from in the same direction of current, that means here current is going in this way, right? And we are also going, sorry, current is going in the opposite way, this way. And we are traveling opposite to the current. Then what happens here are it is positive. Okay, voltage is positive, and here if we are going in the same direction of current, then it is negative, right? We need to know this sign conventions when we are solving a loop problem. Okay, so here we have 2-3 loop problems we have, then I'll remind there also. And in cbse, so state board students, you can relax here for this particular point. Here in Joule's law, it is only for cbse board. So what Joule's law saying is, so this Joule's law of heating, whenever a current passes through a conductor or any material, then it gets heated, right? So this heat is directly proportional to square of the current and the resistance of the material or the device and the temperature, right? So here H is equals to I square RT. Here I is the current, R is resistance, and T is temperature. Okay, so you just need to remember this formula, and we are going to solve problems on this too. Got it? And yes, now let's start the problem, solving problem. So here I have considered most of the questions are previous year questions. Okay, so don't neglect any question. Here, first question is, three resistors A, B, C are connected as shown in the figure. Okay, so here we have a figure, so you can observe that. Here I can see three resistors of equal resistance, and current I is passing through them. Okay, from left to right. What's happening here? Each of them dissipates energy to a maximum of 18 volts. So every resistance, so this consumes 18 volts, 18 watts of power, and it is also 18 watts of power. Here it is also have 18 watts of dissipates 18 watts of power, right? Find the maximum current that can flow through three resistors. So here we need to find the maximum current, right? How do we find it? Here I know the relation between power and current. What is it? P is equals to, I can consider V into I, right? But here we don't have any information about V. So what I'm considering? I'm just considering I square into R. right? So here from this relation, P is equals to I square R, what I can write? Here I can write I square is equals to P square, sorry, P into P by R, right? But here we already know all the values, right? What is P? So every resistor have 18 watts of power dissipation. And what about resistance? Resistance, here we need to consider the total resistance in this circuit. What is the total resistance? Here you can either you can consider. So first we will find maximum current that can flow through three resistors, right? So what I'm taking, first resistor I'm taking, so it is nothing but 2. So here power I square, current I square is equals to 9, right? Then I is nothing but plus 3. Got it? It is 3 volts. So 3 ampere. So here till here it is 3 ampere, right? But what's happening here? Let's apply Kirchhoff law. Then what happens here at this junction? The current, incoming current is 3 ampere and the outgoing current is also 3 ampere. But since it has both resistors are equal, then here 1.5, here 1.5 amperes of current will flow. And we can also check by using this formula. Okay, so what is it? Here again, so current flowing through resistor B and resistor C is nothing but 1.5 amperes. Got it? By using Kirchhoff's law. Then a house has three tube lights. Okay, so okay, it has three tube lights and 20 watts each. That means every tube light has 20 watts, means three tube lights has 60 watts of power. It dissipates 60 watts of power. On the average, all the tube lights are kept on for 5 hours. Okay, so per day it is 5 hours. Then what happens? It is 5 hours, right? Then what happens? It is 120 watt hours. 120 watt hour per day. Then what they're asking, the energy consumed in 30 days, right? It is per day, right? So we need to simply multiply it with 120 into 30. Then what happens here? 36. Okay, 12 threes are 36. 100. Okay, watt hour. So if we want to write it in kilowatt hours, so simply you can write the 3.6 into 1000 watt hours, right? So 1000 watt hours is nothing but kilowatt hour. So P is equals to 3.6 kilowatt hour, or you can also write 3.6 units. Got it? That's it. Next question. How do the resistors 6 ohms and 10 ohms to be connected in a circuit to get minimum resistance? So guys, so here whenever we have we have this type of questions, we need to know that in series combination, always the resistance is maximum. Okay. And in parallel combination, resistance is minimum. Okay. So here they have asked to get minimum resistance, we need to arrange the 6 ohm and 10 ohm resistors in a parallel combination, right? So here parallel combination will look like this, isn't it? So this is 6 ohms and here it is 10 ohms. And now what he is asking, so here we can write, we can connect these two resistors in parallel combination and the resultant resistance of this circuit is 1 by Rs is equals to 1 by 6 plus 1 by 10. Here what is the LCM of these two? 1 by Rs is equals to 1 by, so here I can simply write 10 plus 6 by 60, right? So this will be 16 by 60. Okay, if you cancel these two, then what you'll get here, simply you can write it is 3.1 by 3.75 because 4 table. You can 4 fours and 4 15s, right? 4 fours, 4 ones, 4 and 3.7. So it is somewhere between 3.75. And here what we got, 1 by Rs is equals to 1 by 3.75, right? Don't directly consider this as a total net resultant resistance. No. Here 1 by Rs is equals to 3.5, 3.75. Then Rs is equals to 3.75 ohm. This is the answer. Okay. Now, when a 4 volt battery is connected across unknown resistor. Okay, so here battery is of 4 voltages 4 volts, and there is a current of 100 milliamperes in a circuit. Okay, so what is voltage? Voltage is 4 volts and current is milliamperes, right? 100 milliamperes is nothing but I can write 100 into 10 to the power of milli indicates 10 to the power of minus 3 amperes. So as a overall, it will be 10 square into 10 to the power of it is 0.1 ampere. Got it? Now what is asking the value of resistance in the resistance of the resistor. So what is the relation between velocity, I mean voltage, current and resistance? So simply it is nothing but V is equals to I into R, right? So here we need to find R. So I can write R is equals to V by I. So what is V here? V is 4 into it is 0.1, right? So I can write 4 into 10. Can I? Yes. So 40 ohm. So option B is the right answer. Got it? And the next question is, here we have a very good question. Okay, you need to analyze each and every point, each and note each and every value in this question. So first, let's read the question. A house has 4 tube lights. Okay, let's say it has 4 tube lights and 3 fans. Okay, so it has 3 fans and then 1 television. Okay, so 1 television. Now each tube light draws 40 watts. Okay, so 4 into 40. And each fan draws 80 watts. So 80 into, and one television draws 100 watts. So one television into 100 watts. Got it? And what is asking in the next sentence? On an average, all the tube lights are kept on for 5 hours. So each tube light is kept on for 5 hours, and all the fans are kept for 12 hours. So it is 12 hours, and then one TV is for 6 hours. So this is 6 hours, right? So now what they're asking, find the cost of electric energy. Electric energy is nothing but power they are asking, right? Power consumed for 30 days. In a 30 days with these 3 devices. And one for 1 kilowatt hour, that means for 1 unit, the rate is 3 rupees. Now how much amount of bill will get? Okay, how much amount of current we have used. So for that, what we have to do, we need to find how every each component, I mean each device is using the power. So here first 4 into 40, it is 160 into 5, that is nothing but 300 watt hours. Okay, so TV consumes 300 watt hours of power, and here 3 into what it is 80, so 240 into 12. Here if you multiply 240 into 12, then you will get 2880 watt hours. Okay, and then here 100 into 6, it is simply 600 watt hours, right? So total of, we have all this, if you add all these values, then you will get total of 4280 watt hours of power consumption in 1 day, per 1 day. Okay, but what they asked in 30 days, per 30 days, right? So here I can simply write per 30 days. Okay, per 30 days. So how much it will be? Simply 4280 watt hours into 30, right? So then that will be equals to 128,400. Okay, so isn't it? Two zeros, I have written 2 zeros, and 3 eights is 24. So 4 here and 2 here. 3 twos 8, so 3 to 6 plus 2 it is 8 and 3 fours 12, isn't it right? Okay, so 120 sorry, it is 1,28,400 watt hours, right? But all the power is generally we write it in kilowatt hour, right? So how can we write it? So 1.4 kilowatt hours, kilowatt hours. But here they have mentioned that per kilowatt hour, per 1 kilowatt hour, it is 3 rupees, right? So this is power consumption. Then the amount or the cost we need to find. So what is the cost? Here we have 128.4 watts, kilowatts, and per 1 watt it is 3 rupees, right? So the total will be, if you multiply it, then 3 fours 12, it is 2, and here it is 1. 3 8 24, and it is 5. 25 2 here, and 3 twos 6, and it is 7 8. Okay, 3 ones 3, and here after one digit we have point. Okay, so this is the total amount we need to pay at the end of 30 days for using these three devices. Got it? So this is how we can solve problem like this. Next, here we have one more question that, so a piece of wire of resistance R is cut into 5 equal parts. So here I have a wire. Okay, so here I have this wire, and I have cut this part into 3 equal, not 3, 5 equal parts. Got it? So as a total, this radius, I mean resistance is R, right? So even if I cut this part into, cut this rod into 5 equal parts, then each rod has radius R, isn't it? So it depends on material, right? So it doesn't change. So R we have. And now, so these all the parts are connected in parallel. So this, it is parallel. Like this, we have connected all these wires. I mean all these pieces in parallel combination, right? So what happens here? What they're asking? What happens to the, what is if the equivalent resistance of this combination is R dash? Okay, so the equivalent resistance of this complete circuit is R dash, and each resistance, each rod has a resistance R, right? Then he is asking what is the ratio to the R dash to the R, right? So here all these are in parallel combination, right? I can write 1 by R dash resultant is equals to 1 by R plus 1 by R plus 1 by R. So how many we have? 5. So 1 by R plus 1 by R. So simply I can write 1 by R dash is equals to 5 into 1 by R. Can I? Yes, of course. And if I bring this R to the LHS, then what happens? Here I can write R dash, sorry, R by R dash. That is equals to 5. Got it? Now what is asked? R by R dash, isn't it? So answer is B. Right? And the next question is, a 12-volt battery is connected in a circuit, and to this 4 ohm and 12 ohm resistors are connected in parallel. So here I can see these two resistors. In this first sentence, I can see two resistors and one battery. Oh, and I can imagine that this is the battery and it is connected to two, it is in parallel. Okay, they have mentioned it clearly that these two resistors are in parallel connection, and then parallel, and then 3 ohm resistor is connected in series. Okay, to this arrangement. So this, to this arrangement is, it is connected in series. Draw the electric circuit. So here I can, if you want, you can take one switch, and this is the diagram, right? It is positive and it is negative. Then what is it? And here we need to mention the values as well. So 12 volts battery, and this is 3 ohms resistor, and sorry, no, that is not 3 ohms. So this is 3 ohms, which is in series. So 3 ohms resistor, and this is 4 ohms resistor, and this is 12 ohms resistor, right? And at the end, what he asked us to find the electric current. Current from the circuit. Okay, so to find the current, what we need to know here, we need to know the resistance, resultant resistance. I is equals to V by R, right? We already know that is nothing but 12 volts. Then what about resistor? So resistance, we have three resistors, right? That is 4 volts, 4 ohms and 12 ohms are in uh, parallel. So let's find the resultant resistance of these two. So 1 by 4 plus 1 by 12. So that value is nothing but, so 1 by, if I take 1 by 4 common, then in bracket 1 plus 1 by 3 we will get, right? So 1 by R is equals to simply 1 by 4 into 4 by 3. So 3 get cancelled. So here I got resistance in parallel is nothing but 3 ohms, right? So that means the resultant resistance of this combination is 3 ohms. Okay. Now these 3 ohms and these 3 ohms resistors are in series, right? So series, so resultant resistance is 3 ohms plus 3 ohms, that is nothing but 6 ohms. Now you can substitute that 6 ohms here. So I is equals to V. What is V? 12 volts by what is R? R is nothing but 6, right? So it is nothing but 2 amperes. So this is the value. Now next. Yes, here we have a circuit, and what they have asked here simply the resistance between A and B in the given figure, right? So what is A? Here it is A and here it is B, and the loop is going like this, right? And in this, I can see 10 ohm and 20 ohm and 50 ohm. All these three are in parallel connection, isn't it? These are in parallel connection. Then what about resultant resistance in parallel combination? So simply that is nothing but 1 by R. Okay, let's take resultant resistance in parallel combination, that is equals to 1 by 10 plus 1 by 20 plus 1 by 50, isn't it? Okay, if you take LCM for this, then 10 into 2 into 5, right? Then LCM will be, I mean, in the numerator you will get, it is 10 plus 2 plus 5. Okay. So as a overall, you will get 1 by RP. I mean, the resistance in parallel is nothing but 17 by 100. So here RP you will get 100 by 70, isn't it? I hope you understood this step. Here I have simply taken LCM of these three values. Okay. So if you take LCM, so let's have a LCM 20 and 50. Okay. So first, if you take 10, then 1, 2, 5, right? And then 2, then 1, 1, 5, and then 5, 1, 1, 1. So it is 10 into 2 into 5. That's why I have written 10 into 2 into 5. And in the numerator, 10. So if I divide this LCM with 10, then I remained with 2 into 5. So that is why it is 10. And if 20, if I divide this value with 20, then I remain divides 5 times. So I have written 5. And if I divide this LCM with 50, then it divides 2 times. So it is simply 2, right? I hope you have understood. Now RP, I mean resultant resistance in parallel combination is done. Then what about the resistance series? So here we have it is 10 and I can consider this. It is 10 and this is 100 by 70, isn't it? Now these two are in series combination. So I can find RS is equals to, what is it? So first 10 plus 100 by 17, right? If you consider this denominator is 1, then LCM will be 17 and 10 into 17 it is 170 plus 100, that is nothing but 270 by 17. Okay. If you wanna solve this further, then you will get somewhere between 15.8. Okay, approximately you will get 15.8 ohms. Okay, the value is 15.8 ohms. Got it? So this is how we can solve this question. Next, in the following given circuits, the heat produced in the resistor or combination of resistors connected to 12 volts will be. So if you consider this 1, 2, 3 circuits, so all these circuits have 12 volts battery and 2 volts, 2 amperes, 2 ohms of resistor we have. Okay. So now we need to find the heat produced. But what is the formula to find the heat produced? And this is again from Joule's law of heating. So guys, state board students, you don't need to panic here. So this is only for CBSE. And the formula is I square R T, right? So what is I here, I we don't know, right? So let's find I for the first one. So uh, I A I'm considering. So I'm considering it is A, B, okay, C. I A is nothing but how can I find V by R? So what is V? It is 12 and by R it is 2. So I can get 6 amperes of current here. So HA, I mean current in the first case, uh, it is H is equals to I square RT, right? So what is I here? Anyway, we got I as 6. So 6 into what is R? R is 2 and T we don't know. So simply take T. Okay, so H is equals to 6 are 36. 36 into 2 it is 72 T. Okay, so this is for first one. And what about second? Second case here, what is I? Okay, so no, I is same, but what is R here? R is equals to resultant resistance, right? So R is equals to 2 plus 2. Okay, that is 4 ohms and current I is equals to V by R, right? V is nothing but 12 and current resistance R is equals to 4. So simply current is 3 amperes. So H is equals to I square. That means 3 into 3 into R. R is what? 4 and T. Okay. So 3 threes are 9 into 4 it is 36 T. Okay, in second case we got H is equals to 36. And what about third case? So simply here these two resistors are in parallel combination, right? So 1 by R is equals to 1 by 2 plus 1 by 2, it is nothing but 1 by R is equals to 1. Okay, then R is equals to 1 ohm. Then we need to find current. Current I is equals to V by R, right? So V anyway it is 12 and R. So current is here 12, so 12 amperes. Now H, what about H? H is equals to I square RT. Got it? So I square is nothing but 12 into 12 and R is 1 into T, right? So 12 12s are 144. H is equals to 144 T. Now, if you compare these three values, then just see, same in all cases, no, it is not at all same. And B, minimum in first case, no, minimum in second case, so it is not also not true. Maximum in second case, no, not at all. Maximum is in the third case, so only option D is the right answer. Right? So this is how we can find this question. And we have one more question, that two conducting wires of same material and of equal lengths and equal diameters are first connected in series. Simply read the question again, sentence again. Two conducting wires of same material and equal lengths and equal diameters. Okay, first I am considering this is one wire and with the same length I am considering one more wire. Okay, length is same and since diameter is same then area is also same. Okay, now these two are connected in series. Okay, connected in series and then parallel, right? So first in series combination, what happens to the uh, ratio, I mean not ratio, resistance. So simply resultant resistance is equals to R1 R plus R. Okay, both have resistance R. Okay, R plus R, that is nothing but 2R. And in parallel combination, what happens to the resistance? Here simply this is parallel. So 1 by R is equals to 1 by R. Here 1 by Rs is equals to 1 by R plus 1 by R. So simply it is 2 by R. Then Rs is equals to resultant resistance in parallel is equals to R by 2. So it is decreased, right? So here it is maximum, here it is minimum, as we have discussed it in last problem. And what he's asking, the ratio of heat produced, he's asking, right? So first let's find the ratio of heat produced in series combination. So it is H is equals to I square R T. Okay. So since we need to find the ratio, right? With the uh, information of resistance. So here I can write H is equals to, let's just consider this I square and T common. Okay. I square and R. What is R here? R is 2R. and T. But guys, I depends, what is I? I is equals to V by R, right? Isn't it? That means here in series combination, what is I? I is equals to V by R. Okay, I can write this V square by R square into R into T, right? R get cancelled, so I can find the relation between V R T is V square by R into T. Okay. Now here this H is indirectly proportional. I mean inversely proportional to R, right? So in the first case, H1 is equals to, so okay, here we can simply write H1 is equals to V square. H1 is equals to V square. What is R? It is 2R into T. Okay, that's fine. And H2, I mean in parallel, what happens V square into T. What is R here? R by 2, right? So it will be numerator. Then we have to find the heat ratio of heat produced in series. Series is H1 by H2. We need to find what is H1. It is V square T by 2R. Okay. And what is H2? It is 2V square T by R, right? So V square T get cancelled, R get cancelled and remained with 1 by 2 into 2. So simply it is 1 by 4. Got it? So this is how we can find. So 1 by 4, that is nothing but 1 is to 4. Now, next question. An electric bulb is rated 220 volts and 100 watts. That means V here is 220. Okay. P is 100 watts. Okay, that's fine. And when it is operated on 110 volts, that means here we can consider V1, P1, and here it is V2. V2 is 110 volts. And what happens to the power consumed? P2. What happens to the P2, right? But we have a relation, right? What is the relation between P and V? So simply P is equals to V square by R, right? Right? So here P R is nothing but R is equals to V square by T, isn't it? So let's just consider R is R. It is for the same device, right? Isn't it? We have only considered one device. So R is constant at any voltage. So V1 square V2 square by P2, isn't it? Now I can write from this equation that V1 by P2 is equals to P1 by P2 is equals to V1 by V2 whole square. Okay. Now you need to substitute all the values in this equation. So what is it? So simply, what is this value? P1. What is this P1? It is 100 by P2. Okay. And then what is V1? V1 is 220. V2 is 110 whole square, right? Isn't it ones and twos, right? So that's fine. And 100 by P2 is equals to 2 square is nothing but 4. So I can write P2 is equals to 100 by 4. Then that is equals to 25 watts. So answer is option D. It here. Yes, we have the similar problem that two bulbs, 100 volts and 220 volts and 60 watts and 220 volts. So it is power and it is voltage. It is power and it is voltage. Okay, which one has greater resistance, he is asking. So guys, let me tell you one thing. So without using pen and paper, you can answer this question. Okay, let me tell you how. Here, what is the relation between power and resistance? And when voltage is constant, so we have a formula that P is equals to V squared by R, right? Got it? So P is inversely proportional to R. If P is greater, then R is decreases, right? And he's asking which one has greater resistance. That means which one has a lower power, then it has a higher resistance. So among this, which one has higher lower power? So that is nothing but the second one, obviously. But let me just give you a numerical proof. So what is it? First case. Okay, first what am P1? P1 is equals to 100 watts. And what is V1? It is 220 volts, right? So R is equals to V square by what it is? P. What is V square? It is 220 into 220 by 100. Okay, so 0, 0, 0, 0 get cancelled. And here we will get R is equals to 484 ohms. Okay, this is first case. And what about second case? Simply here also R is equals to B square by P, right? R. What is B square? It is 220 into 220 by P. It is 60. Got it? It is 0 and this is 3. Then it is 11. Okay, so we got R is equals to 220 into 11 by 3. If you solve this, multiply all these values, then you will get the value somewhere around 806. Okay, 806 ohms. Now tell me which one has a greater resistance? This. So second one is obviously has a greater resistance. Got it? Now last one. In the following figure, a potential at A is blank when the potential is at B is 0. So here we need to find the potential at this point, and to find it we need to apply loop law. I have given all four rules, right? If we are going in a loop, if we hit the positive terminal, then our voltage is negative, and if we hit the negative terminal, then it will be positive. And if we are going in a resistor, if we are going in the same direction of current, this is current direction and we are going in this direction, then here also it is negative. And if we are going in the opposite direction of current, then this is current direction and this is our direction, then it will be positive, right? Now by using these four rules, we can write the equation here. First, VA, potential at A, and current is going in this direction and we are also in the same direction, right? So IR. And first it is positive and it is negative. So first we hit a positive terminal. So this is negative 2. And then VB is equals to 0 because sum of, according to loop law, sum of algebraic sum of all the potential across every component is 0. So here anyway VB is 0, right? So I can write VA is equals to IR minus 2. So not minus, it is plus 2. What is I here? 1 ampere into resistance is 5 plus 2, right? 1 into 5, 5 plus 2, that is nothing but 7 volts. Okay, so voltage at this point is 7 volt. Got it? And here one important question. So it says that the figure shows the three cylindrical copper conductors along with their phase areas and length. Okay. So these three has length. First one has length L and area A, and second one has length 3L and area A by 3, and third one has length L by 3 and area 3A. Now what happened? Compare the resistance and resistivity. Resistance. First let's talk about resistance. Okay, first one. Okay, RA. Okay, left or else R1. So what it is? Anyway, R, what is the formula for R is equals to rho L by A, right? And for same rho is equals to RA by L. So first let's talk about R1. R1, rho into rho is constant, and here what is L? L is length is L and A. Okay. And what about R2? R2 again rho into L. What is L? It is 3L by A. What is A? It is A by 3, right? Then I can write R2 is equals to 9 rho L by A, because denominator of the denominator will become numerator. Okay, then R3. R3 is simply rho L by 3 by A. So this becomes R3 is equals to rho L by 9A. Got it? And if I compare all these three, then I can write R1 is to R2 is to R3. Then that becomes rho L by A is to 9 rho L by A is to rho L by 9A. Got it? So from all this, if I cancel rho L by A, then it will become 1 is to 9 is to 1 by 9. Got it? So this is the, here is the comparison between all the resistances. Then what about rho and resistivity? Resistivity does not depend, we already know this, resistivity does not depend on the shape and length, area of cross section, right? So simply rho A, rho B and rho C all are equal. Got it? So this is the relation between resistance and resistivity. Now here we have a question, and look at this circuit diagram carefully. That here this 3 volts battery is connected to two arms, that is AB and CE. In arm AB, we have one resistor that is which has 6 ohms of resistance, and in CE we have two resistors. One is 2 ohms resistor and it is 4 ohm resistor. Now we need to find the total resistance in arm CE. So what is arm CE? It is simply in series, right? So I can write 4 plus 2, that is 6 ohms. Okay, so the total resistance in arm CE is 6 ohm, and the total current drawn from the battery. So current drawn from the battery is nothing but I is equals to V by R, right? So we already know it is V. Okay, voltage is V. Then what about R? Here we have two resistances, that is 6 ohms and 6 ohms are in parallel. So our resultant resistance 1 by R is equals to 1 by 6 plus 1 by 6. So here it is nothing but 2 into 1 by 6. It is 3, 5. So R is equals to, resultant resistance is equals to 3 ohms. So if you substitute this value here, then what happens? Our voltage is, anyway, it is 3 and resistance is 3, right? It is 1 ampere, right? And so this is 1 ampere. And current drawn in each arm, okay? So here this is positive, right? Anyway, from here 3 ohms of current. So till here it is 3 ohms of current, right? But at this point we have a junction. And here in these two junctions, so it is, this arm has 6 ohms resistance and it also has 6 ohm resistance, right? So current divides equally. So it is 1.5 here and 1.5 here. Got it? So in AB it is 1.5, sorry, not 1.5, it is 0.5. Sorry, the total is 1, right? Here it is 1 ampere. So till here it is 1 ampere, and here it is 6 ampere, 6 ohms and 6 ohms. Then a current divides equally, that it will have 0.5 amperes and 0.5 amperes. So answer is this. Okay. Next question. And the last question. Here, what is asking? Calculate the total resistance of the total resistance of the circuit and find the total current in the circuit. So first, total resistance he asked, right? First of all, here R1 and R2 and R3 connected at this junction. So here I can say these two are in parallel and these two R3 and R4 are in series, right? So from this series combination, I can write the resultant R5. I'm considering the resultant of R3 and R4 as R5, and that is nothing but 6 plus 4, that is equals to 10 ohm. Right? Now what happened after finding this resultant? Our circuit becomes like this. At this point we have, so here at this point, here this is R1, it is R5 and this is R2, right? Here R2 and R5, these two are in parallel combination. So here I can find the resultant resistance by using this formula. 1 by R is equals to, okay, let's say this is R6, okay? Now 1 by R2 plus 1 by R5. So what happens here? What is 1 by R2? R2 is, they have mentioned it is 10 plus R5 we got it is 10. So simply it is 2 into 1 by 10, that is nothing but 5. So R6 is equals to 5 ampere. So 5 ohms. Got it? And after finding this, our circuit became, first it is R1 and now it is R6. R1 and R6. These two are in series combination, right? It is 7 and this is 5. So total is of 12 ohms of current we have. Resultant resistance is 12 ohms, and but what we have, it is the total resistance, it is done. Now here's total current, right? So total current in this is V is equals to IR. So I is nothing but V by R. So what is V here? V is simply, they have mentioned it is 24 by R is 12. So simply we have 2 amperes of current in this circuit, right? So guys, this is about all the formulas and all the previous year questions and important numericals from the chapter electric current or electricity. So I hope you have understood all how to attempt a question by using the formulas. Okay, formulas are very important, and also understanding the circuit is also very important in this chapter. Got it? I hope you have understood, and if you like the video and share, subscribe the channel. So guys, we'll meet in the next video, and till then keep learning and bye guys.